angle between two planes. If we have two planes and we know that a plane has a vector normal to the plane or perpendicular to the plane, we call it as the normal vector to that plane. So the angle between two plane, if this is plane 1, this is your plane 2, the angle between two plane is defined by the angle between their normals, that is the perpendicular. So just see here that if this is the theta, this is the theta, this is the angle between two plane, then we have 180 minus theta, that is this is theta, this is 90 minus theta, and 90, this is theta. So 90 minus 90 whole degree, 90 minus 90 minus theta is your theta, which is the angle between your normals, right? Let me show you here. If this is the angle between theta, this is the angle theta. What is this? This is 180 minus theta. But if you talk about the normals, this is the perpendicular, this is the perpendicular, this n2 is perpendicular to plane 2, n1 is perpendicular to plane 1, and the angle between them is nothing but this angle, which is the angle between the plane. So it is actually 90 minus theta, which is actually equal to theta. So we can find out the angle between two planes as the angle between the normals, or the angle between the perpendiculars to the plane. So if this n1 and n2, they are normals to the plane and theta is the angle between the planes, you can simply write the equation of the plane r dot n1 equal to d1, r dot n2 equal to d2, and the theta is simply the angle between the normals of the plane. If you draw it from some common point, we have already known that. So this will be cos theta will be n1 dot n2 by the magnitude of n1 and n2. So the planes, these are perpendicular to each other. If they are perpendicular to each other like this, say a sort of this type of plane, if they are perpendicular, then n1 dot n2, this will be 0. And parallel, if n1, these two are, I'm talking about these two are parallel, because n1 and n2, they are parallel. We can also have a Cartesian form. If theta is the angle between two planes, we know the equation of the plane in the Cartesian form is a1x plus b1y plus c1z plus d1, a2x plus b2y plus c2z plus d2 equal to 0. And the direction ratios of the normal to the planes are simply a1, b1, c1, a2, b2, c2. This is for first plane, this is for second plane. So cos theta will be simply a1, a2, b1, b2, c1, c2, and the square of the coefficients of x, y, z divided. So if the planes are at right angle, what we get? The theta will be 90 degrees, so cos theta will be 0. So cos theta will simply this one, which will be equal to 0. And if they are parallel, then a1 by a2 equal to b1 by b2 equal to c1 by c2. Let us take an example. Find the angle between two planes, these two, using vector method. So we know here that this one is your n1, this one is your n2, because the angle between two planes is the angle between their normals. And we know the equation from this equation n1 and n2, we know, just put it here, cos theta n1 dot n2, just take the dot product of these two vectors. That will be 2 into 3 plus 1 into minus 6 plus minus 2 into minus 2. This will be the result. And how about the magnitude? 2 square plus 1 square plus minus 2 square, 3 square plus 6 square minus 6 square plus minus 2 square, this one. Just divide it and take cos inverse here. This will be, theta will be cos inverse 4 by 21. Find the angle between two planes, these two. So we have just equate it with the Cartesian form. This is the equation of first plane, second plane. So this will be a1x, b1. We know that this is a1, this is b1, this is c1, this is your d1, this is a2, b2, c2, right? So just take these values and put it in the formula. a1, a2, b1, b2, a2, a1, a2, b1, b2, and c1, c2, divided by under root this square plus this square plus this square, and here this square plus this square plus this square. Divide it, you get theta equal to cos inverse 5 root 3 by 21.